AC to DC converter. This lesson deals with a circuit that is commonly found in all adapters and chargers. The circuit includes components like the transformer, the capacitor, and the diode. These bulky but reliable boxes are needed whenever there's a need for electronic gadgets to get power from the outlets. All electronic devices need to be powered up by a DC voltage supply, a supply that is always constant, just like a battery. The outlet, on the other hand, provides a voltage that is AC. During the lesson about diodes, we have been introduced to rectification, a process of AC to DC conversion. The rectified signal may be unidirectional already, but clearly it is not yet constant. This is when the capacitor comes in. By connecting a capacitor at the output, the signal becomes smoother. The humps reduces to smaller ripples. How does the capacitor achieve this? During the time the voltage is increasing, the capacitor is steadily charging up. It stores this voltage even until the original voltage falls down to zero. Yes, the capacitor may discharge some of the voltage, but this process is slow enough that it won't completely discharge by the time the original signal rises up again. So, with the addition of a single capacitor, the voltage now becomes cleaner. Larger capacitors can store a charge longer. Thus, it can filter better and output a more constant and usable voltage. For efficiency purposes, however, there is a more widely used configuration. This is called the bridge rectifier, and it uses 4 diodes constructed this way. This rectifier has the ability to utilize even the negative half swing of the signal, that is otherwise clipped off if only one diode is used. Let's analyze this. During the positive half swing, the signal turns this diode on, and this diode as well. The signal is then passed across the resistor and the capacitor. During the negative half swing, these 2 other diodes will be the ones turned on. The way they're connected forces the signal to go in the same orientation as the one before, and passes the same shape to the resistor and the capacitor. The humps will be more frequent now, so that the capacitor will have less time to discharge, and thus smaller ripples are seen, and the output becomes more desirable. So this is the basic AC to DC conversion process. But there's another component that is also important, the transformer. Transformers convert large AC voltage to lower AC voltages. This component is necessary because AC voltages from the outlets have typically large peak voltages, reaching up to 120 volts. Some places use 220 volts. Electronic devices, on the other hand, are usually low power. So, again, this circuit works by first transforming a large AC voltage to a lower value, for example, 12 volts. Then this voltage becomes rectified by the diodes. And lastly, the capacitor does its filtering to produce a constant DC voltage.